in my hand, I have of playing cards. Okay. I'm going to assume that some would be half before, and I'm also going to assume, okay, that case, right? Either you have played or you have not played. So the way this works is just to show you some random cards. And again, these are just the first. I have a few different cards. One, I see red. Half the cards are black. Okay. I also see a number of tens and 4 aces and 4 sixes, 4 of every single kind. And there are 13 different kinds of cards. Okay? And of those 4, like I'll pull out the 4 queens just because I have 2 of them already. So let me go find the 4 queens. There's 2 of them. They're queens. Black, half are red. Now they all, right? The diamond, that's a spade, right? Spade, clover. I always forget those names. Symbol. So there's only one card in the whole deck that's a queen diamond. Huh? This is a club? This one's a club? This is a club, and that's a spade, right? Yeah. But there's only one card in the whole deck that's queen diamond. There's only 2 queens in the whole deck that are red. There's only 2 queens in the whole deck that are black, and in total there's only 4 queens. Does that make sense? Now it goes from, and that's what this little table here is for. I know it's kind of hard to see, but it starts out at ace. Heck, I can't even read that. Yeah, there's an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, all spades. Then you have them all diamonds. Then you have them all clubs. Then you have them all hearts. And then help you out to label these as aces, jacks, queens, kings. Right? I think one more line. Usually it does better. For some reason. Alright, so let's go through the questions. Cards can have 13 different symbols. Remember, we just said the symbols are these. And be 4 different. How many different cards are there? Whenever, yeah, 52, because there are suites of cards. I bet there's 13 different symbols. So you just take 13 times 4, and there's 52 cards. Actually, we're going to come back to that. Otherwise, we should do this next. Okay. So let's say Luke draws 5 cards randomly. So 2, 3, 4, 5. 2 pairs. That's not bad, right? Let's say he draws 5 cards and gives a card to 5 friends each. So it's actually 6 of you, and then I said, oh, you get the jack, oh, you get the jack, now let's keep it. Okay? How many different ways can he give out different cards to friends? Well, does the order matter? Maybe. Maybe you care whether you got the jack or you got the king or you got the 3. So total, we're going to have draw 5. Doing the math, and assume you're going to type this in the calculator just in simpler. So if you type 52 calculator, you get 11,875,200 if order matters. Now the same problem, if you don't care what order they're in, then you would do 52 C5. In most card games, you don't care what order they're in because you could take the cards and rearrange them. Okay, so most of the time we're going to use C. And if you type that in the calculator, you only get 2 million. $509,960. So more times use the C function where order does not matter because you could usually rearrange cards in your hand. So what is the probability that Luke can draw a card with a spade on it from a 52 card set of cards? So probability is how many you want divided by how many cards are there? 52. Now, it looks like he's just picking one card, so he's going boom, right? Now, if he was picking more than one card, then this would be a little bit more complicated. But he's just throwing down a random card. And we would expect, because spades. Did I get a spade? No. Now did I? No. Now did I? No. It took 4 times. 1 out of 4, right? And it's very similar to that. So you have 52 total cards. 13 are spades. And that actually ends up being 1/4. Let's just agree to write your answer as a decimal. However, you could write it as a percent. Okay? You could write that as 25%. But just to stay consistent, let's just keep it as a decimal, 0.25. Okay. Does that make sense? A school is having guest speakers come in to speak to each classroom. 5 are coming in on 5 different days. And the people coming include Superman, Batman, Thor, Iron Man, and Spider-Man. What is the probability that Iron Man will speak on Monday and Spider-Man will speak on Monday? So we have 5 days, 5 people. Okay. And we have 5 days of the week. So let me make a little table for myself. I have Monday, I have Tuesday, I have Wednesday, I have Thursday, and I have Friday. Truth is, I don't know who's speaking. We did very similar to this, but they said Spider-Man, and it said that Iron Man, right? Well, we don't know. We're trying to find the probability of that actually happening. It would be how many that we're looking for. Well, possible events, you would divide by 4. Correct? You understand why? Because they could speak on Monday, could speak on Tuesday, 3 people that could speak on Wednesday, then there'd be 2 left to pick from on Thursday, and then whoever wasn't picked gets to go on Friday. There's 5 factorial total possibilities. Okay, so probability total goes down there. But the question is, what is the probability that Iron Man speaks on Monday? Well, we're looking for all of Iron Man. So Iron Man, so with all these. So what if this was Iron Man? We would only look at the ones that have Iron Man right there. Only one person could go there, Iron Man. And, so both must be true, Spider-Man is on Friday. So here's Spider-Man. One person. So Iron Man, Spider-Man. So that leaves, because there's 5 people, and you're taking out where Iron Man is first, and you're taking out where Spider-Man is first, that leaves 3 people that could go here. And then once 3 people go here, 3 choices for there, 2 choices for here, 1 choice for there. So of those 5, there are 1 times 2 times 1 times 1. There are where it goes Iron Man, the others arranged. Makes sense if these are fixed and there's only going to be 6 total. Does that make sense? Do you want me to list out the possibilities? Would that help? There's only 6 of them. Yeah. So we could have Spider-Man, it could be Spider, oops, try again. It's supposed to be Iron Man first, right? So it could be Iron Man, and then we have blank, 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 and then this would be Monday, Tuesday, Wednesday, Thursday, Spider-Man, right? So Iron, blank, 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 Spider. Iron, blank, 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 Spider. Iron, blank, 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 Spider on Friday. Iron, blank, 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 Spider. Iron, blank, 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 Spider. Now if you take the other people, Batman, it could be Batman. So we have 3 people left. We have Batman, we have Thor, and we have, right? Those are the 3 people that need to Thursday. So it could go Bat, Super Thor, it could go Thor next, then Bat, then Super. Or it could be Thor, Super, Bat. Or maybe it wasn't Batman or Thor that went Tuesday. Maybe it was Superman. So then you'd have Super, Thor, Bat. Or you have Super, Bat, Thor. So those are the only possibilities. There's six. Six possibilities where Iron Man is first, Spider-Man's last. But total possibilities, we don't know if Iron Man really went first. That's why it's 5 here that could go here, 4 here that could go here, 3, 2, 1. So what you're looking for divided by the total. Okay? So if you type 6 divided by 5 factorial, you get 0.05. Okay, 5%. If you want to write it as 5%, you can. Okay, or 0.05. 6 divided by 120. 0.05. Does that make sense? This stuff is not easy to just think about. Okay. What is the probability that Iron Man will speak on Tuesday and Superman won't speak on Friday? Well, guess what? This is still 5 factorial. There's still 120 total possibilities. 5 factorial. And we still have 5 days of the week. So what is the probability that Iron Man speaks on Tuesday? Iron Man over here. So what number would go up here? 1, right? We're looking for all the possibilities where it goes something, Iron Man, something, 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 right? So we're looking at all the possibilities where Iron Man is there. There's only 1. If that's what we're looking for. And then Superman won't speak on Friday. So this one is not Superman. So if it's not Superman, who's it going to be? Not Iron Man. Iron Man and Iron Man, right? So it's not Superman, Iron Man. So who could it be? The other 3. The other 3 superheroes could go there. So it can't be Iron Man. And we're saying all of them where Superman's not there. So that leaves us how many more people that could go here? If 1 goes here and 3 go there, or 1 goes here and 1 goes here, we don't know. 3 possibilities. We just know it's not Superman. So that's 1 person we could take off, 1 person we could take off, leaving 5 minus 2, 3 people. Does that make sense? So 3 people could go here. And then right here, that leaves 2 people that could go there. Thursday, only 1 person that could go there. 1 times 2 times 1 times 3. 18. And 18 divided by 5 factorial. .15. If you want to write 15%, I don't care. Or 15 out of 100. I'm going to keep on mine as just a decimal, just to be consistent. Percent, 15%. Okay? Same thing. Yeah. Florida has a lottery game called Lotto. It's set up where a participant